Hello everyone, Assalamu alaikum.
আসসালামু আলাইকুম মিস।
ওয়ালাইকুম আসসালাম। How are you all? তোমাদের ঈদ কেমন কাটলো? এক্সাম তো স্টার্ট হয়ে গেছে অলরেডি। কেমন যাচ্ছে?
মিস যাচ্ছে মোটামুটি।
হুম হুম ম্যাথ এক্সাম নাকি খারাপ দিয়েছো? আচ্ছা।
হ্যাঁ মিস।
ওকে, ব্যাপার না। আচ্ছা, তোমরা ম্যানুফ্যাকচারিং এর আগে 2 দিন বন্ধ রাখলা। ম্যানুফ্যাকচারিং কে অনেক কঠিন লাগে তোমাদের?
যেটা মেকানিক্যালদের জন্য এরকম ভাবে রুটিনটা করা লাগছে আর কি।
ও, মেকানিক্যালদের। আচ্ছা, বুঝতে পেরেছি। কারণ ম্যানুফ্যাকচারিং এর আগে তো 2 দিনের বন্ধের দরকার পড়ে না, তাই না? 1 দিন গ্যাপ থাকলেই হয়ে যায়। ওকে, আস্তে, আস্তে আমরা স্টার্ট করি। অনেকেই জয়েন করে ফেলছে। স্ক্রিনটা শেয়ার দিয়ে নিই। ওকে, আই গেস তোমরা এখন দেখতে পাচ্ছ, রাইট? Can you guys see my screen?
Yes, miss.
All right. I guess we can start the review class. It's going to be a very short class. It's already late night. And you guys are already preparing for the exam, right? So I won't take much of your time. A short class, briefing about how you need to study, what things are important, what are not. Mostly we have 5 slides, right? Metal joining, grinding, powder metallurgy, then advanced machining and casting. So among these 5 slides, you will get 120 marks worth of question. So 4 set of questions, each 15 marks. Like each set contains 2 small questions of 15 marks each. All right. So basically, I have designed it like this, that some slides will, the questions will come one whole set. Okay, whole 30 marks question will come from some slide, and from some slide there will be only one single question of 15 marks. All right. So whichever slides we have put more emphasis on the class, those slides you need to focus more on. So let's start with our metal joining methods. I think it was, this is one of the core topics, and since uh, uh, this is since actually this is of much more importance, that's why I kept it in the final syllabus. Otherwise, I usually teach this in the mid syllabus, but since it's very important, I've kept it in the final exam syllabus. So in the metal joining method, you guys have seen a lot of different methods. Mostly for the exam, you will try to ask yourself that what kind of comprehensive questions can be asked from this slide. Okay, can I ask a comprehensive 15 marks question about the welding, types of welding joint? Not really, that won't be much of a difficult question. Rather than, I can ask you something about the shielded metal arc welding, right? It has a lot of different phenomena. This the protective slag layer, the melt pool, the angle, the base metal, the direction. It has a lot of variables. So I can ask detailed questions from this section, right? So just study intuitively that what kind of questions may come up. Use previous year's exam questions as example to uh, give yourself some reference. Okay, so study these methods. Whenever you see some method, try to go online and look up a small video or animation of how it's actually happening, because by reading the slide it's sometimes a little difficult to visualize the whole thing. You need to visualize first, then come back to the slide and read everything. And for the welding methods, there are a few welding methods which are very similar, like TIG, MIG, and SMAW or stick welding, যেটা বলি. So whenever you study something similar, ask yourself that what are the main differences between them? How can I compare them? Which one is better in which scenario? Okay, study like this. So we have a few similar things. TIG, MIG, they're very similar, but they have some only a few major differences. Then submerged arc welding, this is also very critical. You need to find out that why this method is preferred uh, on a few criterias. Okay, oxyfuel gas welding, this was comparatively easier. So, and in between resistance spot welding and resistance seam welding, give these a good read and try to compare them. Like, when will you prefer what kind of joining method? All right. So, and the cracks welding defects are also important. Were there any question about welding defects? I think about the casting defects in the mid exam, there was some questions, right? So from there, you get an idea that if I asked about a defect, you have to name all of the defects and give me a short visual about the defect and answer the question properly. Some of the main problem, what I see in your script is that most of you guys, you just read the slides, you read the slide by heart and you just try to memorize everything and just write it word by word. But actually, we are asking you some complex engineering questions which needs to be answered in that specific way. Always make sure that you are answering my question, not just giving me some random information from the slide. Okay. Uh, One thing I would like to share. Let's see if I have the document. Mhm. ওকে, আই গেস এখন দেখা যাচ্ছে। এই মোবারক কি আছো? Okay, he will probably listen to this. I'm not providing any recording of this class, but you feel free to share this information with your classmates. You can keep some notes. So, can you see my screen? I'm sharing the course outline, right? It's very important that before your exam or while you're studying the whole syllabus, you take a look at the course outline and the course objectives. Okay, so you need to match that. What were my objectives and how can I fulfill them through studying these slides? So our first CO1 or objective one is to define different functions and different manufacturing processes. So there will be some types of definition questions. I will ask some things directly from the slide, like define this process, demonstrate this process. But another objective of our course is to identify some basic manufacturing or production systems based on natural operations, okay, and raw materials. So the highlighted thing here is identify. So there will be some type of questions in your exam. I will ask you to identify manufacturing process. Okay, so to identify, you obviously need a better knowledge on the matter. So read the slides carefully. Uh, Try to understand that in which scenario, which manufacturing processes are preferred. Okay, so you can identify those kinds of processes in the exam. And the third, CO3, this kind of question will also arise. Our objective, course objective 3 is to apply work methods and analyze performances. Okay, so there will be some kind of application and analysis based questions in your exam. Application and analysis based, you can think of it like any kind of mathematical analysis or any kind of real life application. Okay, COPO mapping, uh, you can go through this. I would say not necessary. PO1 is actually very basic. uh, PO is actually our program outcome. Program outcome, the whole, as a whole program, IPE program, and course outcome is this course, manufacturing process courses outcome. So program outcome, you can give it a read. PO1 and PO2, just give it a read, just to understand like what were the objectives and what kind of questions will be asked, because I am trying to fulfill these objectives through my questions and through your answers, right? So you can give this a read. Do you have this document with you? Let's see, did I share this? Introduction. No. Okay, I will share the course outline. So give that a go. And then I think I've covered this whole slide, that you need to compare. Sometimes you will need to compare, sometimes you will need to uh, identify like which type of manufacturing process or joining process, welding process I am referring to. Okay, so I think from the lecture 4, uh, the since a type of casting defect question was already asked in the mid, so don't focus on the metal joining defects, rather than focus on the metal joining processes. Okay, and from the metal joining methods, one whole set of question will be there. Okay, so study this slide very carefully. Then comes grinding process. Grinding is a comparatively easier slide among all the others. So again, same strategy, try to find out what kind of elaborative questions can be asked from here. Use previous year's questions, see all of them. So here, in the first few slides, you will see that the information is mostly for your understanding, not nothing very comprehensive kind of knowledge is being conveyed here. From the, I think from this slide, things go a little in depth. Always feel free to search around the web to get a little in-depth knowledge about all of these matters. So I think from centerless grinding, you can search in depth and study in depth. Tool and cutter grinder, I think this is not so conventional. So I think you can avoid this portion, tool and cutter grinder. But the other things like geometrical specifications, those are important. But the types of grinding wheel, I would say that just keep a rough idea. You don't need to like memorize or learn any kind of images from this type of grinding wheel. All right, just give it a read. You don't need to actually memorize all of these phenomena, like what is the manufacturing, like which stands for what. Give it a read. But our questions are asked uh, in a elaborative manner. I will not ask you that give me the full specification or grinding wheel information. That will be a short question. Rather than I will ask you a in-depth question. So study like that. So truing and dressing are very common question. It always reappears in the exams. And most of the times we see that the finishing operations in the grinding process, those are the sections where some elaborative questions are asked from. So give these, all of these processes, lapping, honing, buffing, give these a read, try to understand how each of them differ from one another. Okay, and try to match them with the COs, objectives. Sometimes I will ask identify type of question. Sometimes I will ask you analyze type of question, or sometimes I will just give you a definition. So grinding process fairly easy. Then let's move on to the next one, powder metallurgy. Powder metallurgy is also, I would say, fairly easy, and also it's very interesting. Interesting in a sense that this is nothing like our conventional methods. we use metal powder. So that's really interesting. Look up some videos about this, uh, about the molten metal to powder transformation. Not much information is given in the slide, so no need to look up in depth. Just have an idea that there are 4 methods available. These are just basic knowledge for you. Give it a read. Means the main process starts from here. The powder metallurgy whole, the process as a whole. Correct. The powder metallurgy process as a whole and the blending and mixing, all of those steps elaborately discussed. Okay, so from here you will need to study in depth. So I can ask you any type of elaborative questions from there. Sintering is something very important. You need to understand that how this differs from uh, any other heating process, and also how the boundaries are formed, how what difference does sintering makes. And this type of curve was sintering curve was already asked in class test, so it can also be repeated. And also the other powder metallurgy processes, we didn't study those very much, so you can skip the other processes. Skip, keep things simple, keep things simple, yet keep things a little in depth. Whatever the topics we have studied, study them very wholeheartedly. Okay, and applications, since you have seen that some application types of questions will be asked, so study the application, like what are the design considerations. We've seen that for powder metallurgy, we need to uh, uh, have some different design considerations. Advantages, disadvantages are also very important. And one thing to note, that some of you may be some of you were maybe confused that are the additional materials part of our syllabus. No, additional materials are never part of your syllabus. It's only just for your knowledge. Like, you can read, you are feel free to gather as much knowledge as you want, but they are not part of our formal syllabus. No question is asked from the additional material. All right, so powder metallurgy, I will also emphasis on this slide. Okay, so read this thoroughly, don't skip anything. And the topics I have mentioned, read them very carefully. You can use books as your reference. The Kalpakijan book is basically our main reference, but some of the things are taken from the different sources in the internet. So you can look up on YouTube for some more additional information. You can look up on you can ask ChatGPT for the differences, differentiating. You guys already know how to study better than me, right? So next we have the advanced manufacturing process. I would say this slide is a little difficult. Difficult in a sense that these type of processes are non-conventional. So these are new to us, and these are processes, meaning that a whole process needs to be studied from start to bottom, start to bottom end, and with the diagram. So this might uh, come a little difficult for you. In the modern machining processes, we have studied electrical discharge machining, EDM, which was the sinker EDM. This was the thing that had the most uh, uh, amount of variables. It had tool material, wear ratios, a lot of information on EDM was shared because it's actually a very common method. EDM is widely used. Then we have electron beam machining, EBM, and we have another one, LBM, laser beam machining. These are very similar in nature. These are very similar in application as well, but they have some vital differences. So whenever studying similar methods, just study their differences as well. And for all of these processes, try to learn at least the basics of the uh, illustration, okay? The schematic diagram of these processes, try to learn these as well. Mm, laser beam, then we have electrochemical grinding. I think these four, we have these uh, four major machining processes, advanced machining processes. So just study these four. Focus on comparing and focus on the applications. I think you can put more emphasis on the first three. The last one, electrochemical grinding, I can make it easier for you that electrochemical grinding is less important than those first three, okay? So if you learn the first three and try to do a comparative analysis, that'll be good. Good enough knowledge. All right. And always try to answer the question rather than just giving information from slides. Try to answer the question, whatever is asked. Sometimes you are asked to identify a machining process. So if you correctly identify it, very good. If you are incorrect, then usually you get some partial marks for the degree of uh, correctness you have. Okay, so if you are like 50% on the right track, so you get some partial marks. If you are completely off the track, then you don't, unfortunately you don't get any marks for that. Okay. And I have seen that sometimes students write irrelevant information just to fill up the pages. You only have 2 hours. It's very limited time. In 2 hours, you have to answer 120 marks worth of question. So it's already very difficult for you. You don't need to write unnecessary things that are not related. You don't need to write whatever you write in a way that is uh, that I can understand, obviously. Now, for me personally, readability is very important. Sometimes some of you students write in a manner that I cannot read, like the handwriting is in a manner, very cursive way that it's not readable. So that's one problem. If we put that aside, then your comprehension should be good. Like whatever you are writing, I should be able to read and comprehend from that. So I can understand that you have a good knowledge on that matter. Whenever I see that a student has written something irrelevant, uh, I uh, on the first glance, I feel like this student doesn't know anything, so they're just trying to throw a dart in the dark. So it definitely decreases your chances of getting good marks, right? So try to write the correct things. Try to write only the things that are asked. No need to write irrelevant information. No need to write very long answers. Rather concise yet very arranged answers are preferred. So the last slide is casting design concept. This will also, I would say that this is one of the most important slides. This is the last slide, most important slide, and one of the more difficult slides. Okay. So here you will need to study from top to bottom, everything. Basically, this is an application-based slide. So you've seen the CO3 outcome 3, right? It was application and analysis. So mostly from this casting design concept chapter, application types of question and analysis type of questions are asked, because here we have some considerations, and using those we can design anything. We can design any kind of mold, any kind of pattern. We can apply these fundamentals to create something new. So any kind of application based question might come from here. So read it thoroughly top to bottom. Vertical gating, bottom gating, and I have shown you the analysis of aspirational effect, right? For the vertical gating and bottom gating, in both cases, I have shown you the analysis of aspirational effect, meaning that the fact that the sprue should be tapered and actually parabolical in a way in a way to reduce the aspirational effects. So those things you need to study. Like from here we actually get the mathematical analysis of the aspirational effect, so these things are very important. This mathematical analysis, did I show this in class? The TF, mold filling time. So the analysis of mold filling, this is also important. It's not like that you have to learn this by heart from top to bottom. মুখস্থ করতে হবে না পুরাটা, কিন্তু you have to understand the process that if I ask, you can analyze this kind of bottom gating system or a vertical gating system. Okay, you have to understand that you have to be able to use Bernoulli's equation in two different points and come to a conclusion. Okay, and aspirational effect is very important.
Ma'am,
Yes, yes.
ma'am, do we need to draw the figures while deriving the equation?
Figures of
Ma'am, deriving the equation, do we need to draw the figures of bottom gating or?
hmm although it depends on the question, but I would suggest you draw a simple figure, because here we are referring to point number 1, point number 2, point number 3. If you don't have a figure, how will I understand which is point number 1, point number 2? Figure is also helpful for you also, because you will say that applying Bernoulli's equation in point 1 and 2. But where is the point 1 and 2 if you don't have the figure? Okay, I'm not saying that I will give you this kind of proof. I'm saying that you should be able to apply Bernoulli's equation in bottom gating or vertical gating. All right.
Yes, ma'am.
And aspirational effect, I have shown you in a different manner without using R is basically something that can be avoided. R is basically the ratio of A3 and A2. So if you just use the ratio as it is, A3 by A2, then you can just uh, do this as I have shown you in the class. You can see your lecture notes for this aspirational effects. And while showing the aspirational effect, please draw a diagram like this to also visually indicate it. Okay. Whenever you are showing this kind of changes, like you are showing this kind of flow changes, draw a small visual to fully demonstrate it. So I think these last two slides, these are the most important, because these are the implementation of whatever you have learned throughout this chapter. So in this first image, all of the criterias we have learned, the pouring basin should be there, a strainer should be there, a splash core, a skim bob. All of these things are incorporated. And in the second image, we have incorporated all of the design consideration. If this depth is D, then this should be, the sprue base should be 2.5 times the diameter. Yeah, all of those things combined make a proper, not perfect one, but a proper gating system. Okay, so I can ask you, like, design proper gating systems according to all of these considerations. So those are the application kind of questions. So I can give you different types of problems, and you might have to apply those problems according to these design considerations. Okay, and I've already mentioned in the class that I will not give math questions from here, and additional materials are also not included, so you can study until this portion. All right, and this is a very important slide. So i'm not I'm not declaring like how many marks of question will be here from will be asked from here, but this is an important slide. All right, so do you have any other questions, any other problems?
ম্যাম, আম, আপনি যে লাস্টে বললেন যে অ্যাপ্লিকেশন বেসড প্রবলেম আসবে লাস্টের স্লাইড গুলো থেকে, ওগুলা মানে কোথা থেকে প্র্যাকটিস করব, এটা যদি একটু বলতেন, বা লাইক গিভ মি এনি টাইপ অফ আইডিয়াস যেখান থেকে আমি লাইক প্র্যাকটিস করে যেতে পারবো যে এই জিনিসটা এভাবে এভাবে।
Obviously everything will be asked from within the slide. Okay, তোমাকে মানে স্লাইড মানে কি সিলেবাস, উইদিন দ্য সিলেবাস তোমাকে সবকিছু আসবে। এখন অ্যাপ্লিকেশন বেসড কিভাবে প্র্যাকটিস করবা, তোমার এই যে দেখো তুমি যা যা পড়ছো, তুমি এই স্লাইডটা একবার ভালোভাবে পড়লে তুমি লাস্টে নিজেই একটা অ্যাপ্লিকেশন বেসড কোয়েশ্চেন পেয়ে যাবা। স্লাইডে এই যে দেখো কি কি আছে, রানার ডিজাইনের কনসিডারেশন কি কি করতে হবে, গেটস যখন ডিজাইন করব কখন কিভাবে লোকেট করতে হবে, মোল্ডের ফিচার কি কি দিতে হবে, মোল্ডের লেআউট, হ্যাঁ, স্প্রু এর ডিজাইন, স্প্রু হবে প্যারাবোলিক্যাল, সব কিছু তোমার গাইডলাইন দেওয়া আছে। এগুলো হলো
Okay, ma'am.
গাইডলাইন, এগুলো ইউজ করে তুমি একটা কিছু ডিজাইন করলা, ধরো একটা প্রপার গেটিং সিস্টেম ডিজাইন করলা, সেটা হলো একটা অ্যাপ্লিকেশন বেসড কোয়েশ্চেন। ঠিক আছে,
Okay, ma'am.
এভরিথিং ইন দ্য স্লাইডস তুমি নিজেই একটু চিন্তা করে বের করো যে কি ধরনের অ্যাপ্লিকেশন বেসড আসতে পারে। ঠিক আছে, তুমি হচ্ছে ফার্স্টে যেটা পড়ছো, ট্রাই টু কানেক্ট ইয়োর থিওরি। এই যে শুরু থেকে আমাদের মোটামুটি এই এত এই যে 17, 12, 18, 19 পেজ পর্যন্ত, 20 পেজ পর্যন্ত হচ্ছিল আমাদের শুধু থিওরি গাইডলাইন্স, কিভাবে কি ডিজাইন করব। তারপরে হচ্ছিল আমাদের শুরু হয়েছে যে রিয়েল ডিজাইন গুলো, তাহলে কিভাবে ডিজাইনে কি কি চেঞ্জেস আনলে তাহলে আমি ওইটা মিটিগেট করতে পারবো। হ্যাঁ, এইভাবেই তুমি বুঝে বুঝে পড়ার ট্রাই করো, ট্রাই টু আন্ডারস্ট্যান্ড হোয়াট ইউ আর রিডিং and connect it with the real life. I won't suggest like I will ask you something extraordinary. Application based মানে যে অনেক কঠিন এরকম না, এক্সট্রাঅর্ডিনারি না। আমি অবশ্যই আমাদের সিলেবাসের মধ্যে থেকেই জিজ্ঞেস করব তুমি যা পড়ছো সেটাকে অ্যাপ্লাই করে তুমি কিছু ডিজাইন করতে পারো কিনা, একটা গেটিং সিস্টেম বানাতে পারো কিনা, একটা প্যাটার্ন বানাতে পারো কিনা, এই টাইপের কোয়েশ্চেন আস্ক করা হবে।
Okay,
ঠিক
ma'am.
আছে,
Thank you so much.
ওকে, এনিথিং এলস? আমি আচ্ছা আমারই কিছু বলার ছিল, কোর্স আউটলাইন শেয়ার করে দিচ্ছি। আরেকটা জিনিস তোমাদের a few students, হ্যাঁ only a few, দাঁড়াও একটু শেয়ার করতে চাচ্ছি, only a few students যাদেরকে নিয়ে একটু সমস্যা হচ্ছে সেটা হলো তোমাদের অ্যাটেন্ডেন্স, কয়েকজনের অ্যাটেন্ডেন্স খুবই কম। হুম আমাদের উই ডোন্ট হ্যাভ এনি মার্কস অন অ্যাটেন্ডেন্স, বাট আমাদের একটা মিনিমাম ক্রাইটেরিয়া থাকে অ্যাটেন্ডেন্সের। হ্যাঁ, যেটা আমি হচ্ছিল আমি ইউজুয়ালি এত স্ট্রিক্ট না দেখে আমি কিছু বলি না, কিন্তু তোমাদের যে আমাদের নর্মাল নিয়ম অনুযায়ী তোমরা জানো যে 75% কম অ্যাটেন্ডেন্স চলে আসলে তোমাকে আর পরীক্ষায় বসতে দেওয়ার কথা না। ঠিক আছে, 75 এর কম অ্যাটেন্ডেন্স আসলে I'm not supposed to allow you to sit for the final examination. So 75 এর কম 74 যারা আছো তাদেরকে কনসিডার করা যেতে পারে, কিন্তু 67% আছে আইডি 2116 ফারহা তাসনিম। I don't know what happened to her. 67% attendance, আরেকজন 67% attendance 122 আলমাহি মুক্তাদির। জানি না তোমরা আমাকে কখনো
ম্যাম
রিচ আউট
মাহি
করো নাই।
মুক্তাদির নাই।
আচ্ছা আচ্ছা, হ্যাঁ 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 22 তো নাই। হ্যাঁ, না না থেকেও ওর তো ভালোই অ্যাটেন্ডেন্স 67%, এত কিভাবে? ও এতগুলো ক্লাস অ্যাটেন্ড করছে, এই মেয়েটার কি হয়েছে? 116 জানি না, 74% ঠিক আছে, সমস্যা নেই, ওটা ধরো যে এক্সকিউজ করে দিলাম। কিন্তু এই যে এরকম থাকলে হয় কি, আমি আমি অ্যাকাউন্টেবল থেকে যাব যে তুমি আমার ক্লাস না করে আমি তোমাকে এক্সামে বসতে দিচ্ছি। এখন আমি আমার কোর্স যেহেতু আমি একা নিচ্ছি, সো আমার প্যারা নাই। তুমি এক্সামের জন্য তোমার যদি মনে হয় একটা ক্লাস না করেও তুমি এক্সামে বসবা, আমার পার্সোনালি কোনো সমস্যা নেই, আমি বসতে দিব। কিন্তু অন্যান্য কোর্সে দেখা যাবে যে টিচাররা তোমাকে অ্যালাউ করবে না। ঠিক আছে, তোমাদের তো সামনে থেকে সবগুলো মানে তোমরা তো সব সময়ই এরকম স্ট্রাকচারেই পরীক্ষা দিয়ে আসতেছো যে অ্যাটেন্ডেন্সে মার্কস নাই কিন্তু মিনিমাম 75% মেনটেন করতে হয়। তো সেটা করার চেষ্টা করো। সামনেও তোমাদের সাথে কোর্স আছে, সো সামনের সেমিস্টার গুলোতেও এটা খেয়াল খেয়াল রাখার ট্রাই করবা যে 75% এর কম যেন না হয়। হুম 75% কম হলে নেক্সট সেমিস্টার থেকে আমরা আর একটু স্ট্রিক্ট থাকবো। নেক্সট সেমিস্টারে হেড স্যারের সাথে তোমাদের সাথে ক্লাস থাকবে একসাথে, হাইব্রিড মোডে ক্লাস থাকবে। কিছু ক্লাস হেড স্যার নিবে, কিছু ক্লাস আমি নিব। তখন কিন্তু আমি কোনো ধরনেরই কোনো মার্সি দেখাতে পারবো না। সো এখন থেকে এই ধরনের বিহেভিয়ার কারেক্ট করো। 75% অ্যাটেন্ডেন্স ইজ মিনিমাম, না হলে কিন্তু নেক্সট সেমিস্টার থেকে আর এক্সামে বসা যাবে না। আর আমি তোমাদের ক্লাস টেস্ট 4 এর মার্কস শেয়ার করা হয়নি, আমি দেখেছি সবাই ভালো পেয়েছো, ওই 15, 14, 13 এরকম পেয়েছো সবাই, শেয়ার করা হয়নি। সো আর দরকার আছে শেয়ার করার? আচ্ছা, তাহলে আমরা মোটামুটি আমাদের এখানে এন্ড করতে পারছি আমাদের সেশনটা। আর কারো কোনো কোয়েশ্চেন আছে কি এক্সাম নিয়ে, বা কিভাবে পড়বা, স্টাডি রিলেটেড, এনিথিং এলস? Okay, then we are ending this session, all right?
Assalamu alaikum.
Okay, thank you for joining. Walaikum assalam. Good luck for your exams.
Assalamu alaikum.
ম্যাম।
Assalamu alaikum.